Today we're going to talk about the rate of change, which is defined as a change in one quantity relative to the change in another quantity. The key word here is the fact that we're looking at the change in each of the variables and we're comparing them to each other. So if you think back to our slope equation where we have m equals y2 minus y1 all over x2 minus x1. If we look at the numerator, we're getting the difference in the y values. So in our first example here, we have a distance and time graph. So our y values is distance. Our y2 is 5 and our y1 is 0. When I take the difference in it, I'm getting my rise of 5. So the difference in the variable distance is 5. When I look at my denominator, I have x2 minus x1. In this context, my x2 is 20, my x1 is 0. When I take the difference, I have a run of 20. So the change in the quantity of time is 20. So the rate of change is essentially similar to our slope equation, which is either the difference in the y values or the difference in x values, or we can talk about rise and run. So in this example here, our rise was 5 and our run was 20. When I take that value, I get 0.25. What this 0.25 means though is that for every minute, which was our time, I move 0.25 kilometers. So 0.25 kilometers for every minute. So the difference between our rate of change and our slope is that we have units where we talk about the change in one variable over the change in another variable. So let's apply this to our example 2, where we have volume decreasing as distance increases. So here, if we look at our rate of change, we have our y2, which is our volume 2, minus our volume 1, all over our distance 2 minus our distance 1. So we have volume 2, which is 5, subtract our volume 1, which is 65, all over our distance, which is 500, subtracted by our first distance, which is 0. When I take those values, I have minus 60 all over 500. So our minus 60 represents the fact that we're decreasing 60 liters over the time of 500 kilometers. That value gives us negative 0.12, and our units are liters per kilometer. So what this rate of change tells us is that I'm decreasing 0.12 liters every kilometer. So you can think of this as our gas consumption example, where every time I drive a kilometer, my car uses 0.12 liters of gasoline. So let's take this on another example when we look at two distant time graphs. How this rate of change helps us is that we can look at the slope, which is our rate of change, and we can notice that in this line we have a rate of change of 2. In this line we have a rate of change of 3. This is 2 meters per hour and this is 3 meters per hour. So which one has the faster rate of change? That would be the second graph here, because it changes 3 meters for every hour, whereas the first graph changed 2 meters for every hour. So the rate of change can help us figure out how fast something is changing compared to a specific other variable, which in this case was time.